Welcome to day one of 5.5 notes. We're actually going to split this into 3 or 4 different days. There is quite a lot of material on multiple angle and product to sum formulas. The first category here involves the functions of multiple angles such as sine KU and cosine KU. What that means is they could have a 2, a 3, a 4, whatever out in front of your angle that is going to change your graph and then ultimately your solutions if you are looking for specific points. Each one of these just goes through kind of what you're going to see here. The key is really trying to get this into some sort of form that either converts them to the double angle formulas or converts them to...
Just a reminder, please enter in your lunch count. Please enter in your lunch count.
The different types that go with each type of double angle. Okay, so let's take a look at this one here. Now, first off, if I take a look at this, I notice right away, since we are talking about double angles and multiple angle formulas, that I have a sine 2x, which would be a double angle. So if you check out the sine 2x formula, you can convert this to something that would allow you to factor this out and then ultimately to solve and really understand you're looking for, hey, when does this thing cross 0? All right, so let's go ahead and convert this. We'd have 2 sine x, and then we also have cosine x equals 0. Okay, so now that you have that, you can notice that there is something in common in both of these. All right, so if you go ahead and you take those out, so you factor monomial and you put it out front of this different equation here. All right. Okay, so now I have 2 cosine x out front. I have a 1 plus sine x remaining inside of my parentheses. All right, so at this point, you can set both of these equal to 0. So this one here and this one here. I would get cosine x equals 0. I would also get sine x equals -1. Okay, so that is if you solve them both. Your next step would be to go to your unit circle. It does not have a limited interval on this one. So you would have to go ahead and put the 2 and pi that goes with both of these. So if I look at cosine x equals 0, it will equal 0 at 2 different positions. It will equal 0 at pi over 2. Of course, we do have to put plus 2n pi. It will also equal 0 at 3 pi over 2 plus 2n pi. Now, of course, this one goes 2 pi around. You can look for solutions in that. The reason I mention that is there is a time when it does not do that, and that's with tangent and cotangent. Now, if you check out sine x, when it equals -1, it's going to also be at 3 pi over 2. So in fact, you already have that solution, so you do not have to find that out. All right, and then at the end here, we'll try to go through some different graphic calculators that allows you to check your answer. Okay, so it says use a double angle formula to rewrite the equation. And then it says, then sketch the graph of an equation over the interval 0 to 2 pi. Okay, so first off, if I want to go ahead and rewrite this, I'm going to check my formulas. My formulas here being the double angle formulas. Really, when I look at it, I don't have anything that matches it. So my next option is, can I factor something out of the right side? All right, so you can't change this. You can still have y equals, but you can go ahead and you can put a 2 out front. I'd have a 2 cosine squared x remaining minus 1. Okay, now, if you check out your double angle formula for cosine, there is going to be something I can replace that with. Now, that's a pretty hard graph right now. So what I'm going to do is I'm going to go ahead and I'm going to replace cosine squared with cosine 2x. All right, so it does ask us to go ahead and to make a graph of this. All right, so if I do that, first off, it does give us that interval. So I'm going to go ahead I'm going to draw my graph in. All right. Since it's going to 2 pi, I'm going to go ahead and put a pi over 2 here, a pi, a 3 pi over 2, and then 2 pi. Now, the reason I do that is because that would be the parent function of cosine. Now, keep in mind, cosine, it starts at its amplitude, so it starts at 1. All right, it does not start at 0 if we were going to the right and staying positive. Okay, so things that you need to understand here. The 2 would be your amplitude. All right, that would mean that I have to go up 2 here and down 2, and it would stay within that amplitude. All right. The second thing would be this 2 out in front of the cosine would dictate its period. Okay, so therefore, if I go ahead, if you guys remember period, it's 2 pi over b. Okay, well b happens to be 2 here. Therefore, this period would be pi. So it actually have a full period when it hits pi. So in fact, if we go to 0 to 2 pi, you should have 2 full periods. All right. Okay, so first off, it starts at 2, a half away here, since a full period is all the way out to pi. Okay, this one here would have to go through here and hit halfway, go up, go here, and then it would finish right there. Now we have to do that again, so it hit halfway between these two. Okay, be a fourth of the way, and then halfway, 3/4 of the way, and then full. All right, and I may have gotten a little excited on this last one, so I'm going to adjust that. So I'm going to go ahead and make sure I hit the 2 there. Okay, so that is 0 to 2 pi. So again, it goes through 2 full periods. It doesn't have to be perfect looking, but just understand that a full period is going to occur every 5 periods. Okay, so this will actually be the last one. We're going to really take this slow. It is a springtime and we have lots of stuff going on right now. It seems like we are struggling to have a full class on a daily basis. Okay, so it says use the following to find 2 theta, cosine 2 theta, cosine 2 theta, and tangent 2 theta. It also gives us some stipulations here. All right. Okay, so since it has to be between 270 and 360 degrees, I'm going to go ahead, I'm going to draw a XY coordinate plane. It says 5/13 is the cosine, so that means the adjacent side of this triangle, which has to be written like this. This would be the central angle here. This side here would be a 5. Hypotenuse would be a positive 13. Okay, this is going to be a 5, 12, 13 triangle. It's a Pythagorean triple. So that side then would have to be negative 12 since we are in the 4th quadrant. Okay, so ways that we need to solve this. Sine 2 theta. All right. So if I check out my sine 2 theta, it's pretty hard to solve right now as a double angle, but I can convert this using my formulas. So I'm going to do that. So I have 2 sine theta cosine theta. Okay. So since the output of both of these is found on your triangle that you drew, you can go ahead and you can put those in. So sine theta, all right, would be opposite hypotenuse. Cosine theta, which we already have, would be 5/13. Okay, so if I go ahead and I work this out, we would have I would probably go 5 times 12 first, which gives me a 60, times 2 is 120. So I get negative 120, and then 13 squared is 169. Okay, so we have sine 2 theta, and there would be your answer. Okay, x1. So here we have cosine 2 theta. All right. You have some different options with cosine double angle here. The easiest way I think here would probably just be to use the cosine squared theta, and then it'd be minus sine squared theta. Okay. That's not the only way you can do this. You could do it with either other one here, but since I know that I'm going to have to square these, I'm going to plug the fractions in, and then I'm going to square them, and then I'm going to go ahead and subtract it. Okay, so once I have this, all right, cosine squared theta, I'm going to go ahead and write the cosine squared in, which is 5 over 13. That is squared, minus, same thing with sine, we got negative 12 over 13 squared, which is going to end up being positive since we do have something squared there. Extend my page, all right. So we have squared, so this would be 25 over 169. Minus here, we'd have a 144 over 169. Now that stays negative since the squared would come first in the order of operations with the exponent is coming first. All right, so, and then it's just a matter of subtracting and then simplifying if you can. All right, so we have 119 over 169 cosine 2 theta. Okay. Okay, so we have the sine now, we have the cosine double angle, and now we're going to go ahead and do the tangent one, which can be tricky sometimes because we do have a rational expression with your tangent. So we have tangent 2 theta. Let's go 2 tangent theta. So I'm just writing the formula out. 1 minus tangent squared theta. Okay. So once I have that, then I can start working on this, looking at my triangle. All right. So we have 2 in parentheses. We have negative 12 over 13. 1 minus tangent squared again. So we got negative 12 over 13 squared. Okay, so once I get this far, I would take care of the squared. I'm going to also multiply this 2 times the 12. So I get negative 24 over 13. All right, the second one squared would be 1 minus 144 over 169. Oh, that is a mistake. We need to have 12 over 5 here. So the ratio should be negative 12 over 5. Well, of course, it's opposite adjacent. I wrote the sign out, so I went back and I changed it. So we have negative 12 over 5. There we go. Okay, so same process, just different ratio here. All right, I still have negative 24 over 5. And then here I would still square it. I would have 1 minus. This one here is a 144. And then this here is a 25. Now, to make this easier, I'm going to go ahead, since I have a smart board, I can go ahead, I'm going to erase this 1 out in front. I'm going to put 25 over 25. Because I know that if I go ahead and divide these, it'd be a flip and multiply. All right, so 25 here, we just did this. This is 119. If I subtract them, I still have negative 24 over 5 on top. This then turns into 119 over 25. Okay, and then I would write it like this. I'd go negative 24 over 5, and then it'd be multiplied. You'd flip the bottom one here. It'd be negative 25 over 119. Okay, so I would go ahead and simplify what I can. So that's a 5, all right? I don't believe you can do anything else here as far as a simplifying goes. Okay, so the tangent 2 theta, 24 times 5, I would just take 5 times 4, which is 20, and then take 5 times 20, which is 100. So it'd be negative 120. Actually be positive 120 since there's 2 negatives over 119. So there is your tangent 2 theta. So there's all of your double angles working off of that triangle. And like I said, we'll try to split this up into 3 different days, possibly 4. So that actually concludes day 1 notes on section 5.5.